The yellow piece of equipment that you see here is the modified heister that we use to remove the main engines from the orbiter. This is one of the first things that we do after the orbiter returns from a mission and is back in the orbiter processing facility. Removing engines is a very slow and methodical process of ensuring everything is lined up correctly as the engines are removed from the aft compartment. Each engine is 14 feet long and 7.5 feet wide, providing 375,000 pounds of thrust during liftoff. As each engine is removed, it is transported to the engine shop located next to Orbiter Processing Facility number 3. Engineers and technicians then refurbish the engines in preparation for their next use. During this processing flow, we also remove the orbiter boom sensor system, which is more commonly referred to as the boom. We use the yellow strong back that you see here and overhead cranes to lift the boom out of the payload bay and set it down in the transfer aisle of the orbiter processing facility. On orbit, the boom is used as an extension of the shuttle arm, providing the capability to inspect the tiles on the lower surface of the orbiter. Clean room garments must be worn by personnel when working in the payload bay, and fall protection harnesses are required when standing on the platforms next to the payload bay. After performing the necessary inspections with the boom removed from the orbiter, we use the same lifting process to reinstall the boom back into the payload bay. On May 7th, external tank 132 arrived by barge from the Michoud Assembly Facility in Louisiana. The barge, named Pegasus, is 200 feet long and 35 feet wide and was built specifically for transporting the external tank. Within the confines of the turn basin, a commercial tug assists Pegasus as it maneuvers up to the dock. Once on dock, we use the external tank transporter to move the tank off the barge and over to the vehicle assembly building. While the entire offload process takes technicians and engineers approximately 2 hours, the actual travel time is only 10 minutes for the quarter-mile trip. Here is a close-up view of the nose cone, which has the liquid oxygen vent valve and fairing. At the opposite end, the aft bipod struts and propellant feed lines connect to the orbiter. The tank is 154 feet long, 27.5 feet in diameter, and holds over 500,000 gallons of propellant. The function of the external tank is to provide liquid hydrogen and liquid oxygen to the 3 Space Shuttle main engines. The outside of the tank is covered in a polyurethane foam that protects it from extreme temperature variations. Here you see the tank in its final position mated to the solid rocket boosters. Due to the intertank foam loss seen during the STS-127 launch, it was necessary to test the adhesive bonding of the foam on ET-132. This was done by performing plug pulls of selected areas of the intertank foam. Experts from the Michoud Assembly Facility, where the tanks are manufactured, came to KSC to support the effort. 188 pull tests were conducted, and all test results were nominal. After spending 119 days in the orbiter processing facility, Discovery is ready to move to the vehicle assembly building, where it will be mated to the external tank and the solid rocket boosters. Similar to the tank transporter we saw earlier, the orbiter has a transporter as well. The Orbiter Transport System, or OTS, has 76 wheels on 19 axles and was built specifically for the orbiter. Once all testing and checkout of the orbiter is complete, the OTS slowly pulls out of the orbiter processing facility to make the 30-minute trip to the vehicle assembly building. The transporter can travel 12 miles per hour when it is not carrying an orbiter, but only 2 miles per hour with an orbiter. Discovery is secured to the transporter using the same attach points that will eventually connect it to the external tank. The orbiter is 122 feet long with a 78-foot wingspan. Once Discovery is safely in the vehicle assembly building, we begin the process of lifting the orbiter off the transporter and attaching it to the external tank. A sling is connected to the orbiter so that cranes can lift Discovery and move it into the vertical position. Lifting the 200,000-pound orbiter requires use of a 325-ton crane and a 250-ton crane. Once Discovery is hanging in the vertical position, the smaller of the 2 cranes is disconnected, and the larger crane lifts the orbiter up and over the transom into the integration cell. It takes approximately 12 hours to lift the orbiter and get it into the mate position. Technicians closely monitor the movement of the orbiter and are in radio contact with the crane operators at all times. Here you can see the Space Shuttle main engines with their red protective engine covers that are removed before flight. As the orbiter is lowered into the mate position, the external tank comes into view. Now you can see the left-hand wing as Discovery is carefully lowered into place. Once in place, the orbiter is bolted to the external tank at 3 attach points using large frangible nuts. After liftoff, following main engine cutoff, break the nuts, allowing the tank to separate from the orbiter and disintegrate as it falls through the atmosphere. Now that the orbiter has been mated, we are ready to move the complete shuttle stack out to the launch pad. The stack is moved by a crawler transporter which weighs 6 million pounds and uses 150 gallons of diesel fuel per mile. Instead of wheels, the crawler has 8 tracks with 57 cleats per track. Each cleat weighs 1 ton. The crawler is 131 feet long by 114 feet wide, which is comparable in size to the infield of a regulation baseball field. The gravel crawlerway is 130 feet wide, similar in size to an 8-lane highway. Two 40-foot gravel strips are separated by a 50-foot grass median. The gravel is 7 feet deep and can withstand 17 million pounds. River rocks the size of baseballs are quickly crushed to sand under the extreme weight. Therefore, the gravel must be replaced on a regular basis. At a speed of less than 1 mile per hour, it normally takes approximately 8 hours to travel just over 3 miles from the vehicle assembly building to Pad A. Due to the large amount of rain Kennedy Space Center received at the end of July, the crawlerway was wetter than usual during Discovery's recent trip to Pad A. Because of this, the crawler transporter was forced to travel even slower than usual and stopped multiple times along the way to remove mud from the cleats and gears. After a long 12-hour journey, Discovery arrived at the launch pad on the afternoon of August 4th. In order to reach the pad surface, the crawler transporter must travel up the 5% incline of the pad slope. During this incline, the hydraulics of the crawler transporter ensures the surface of the 12 million pound mobile launch platform and shuttle stack remains level. Once at the launch pad, we spend about a month doing a full system checkout of the tank, boosters, and orbiter in preparation for launch. STS-128 is the 128th Space Shuttle mission and Discovery's 37th flight.